Okay, let's review. What makes two things similar? Angles and sides need to be what though? Do they look congruent here?
No.
Yes. Does this look like it's the same size as that? No.
Well, all the sides of the curve are big.
They need to be proportional. Does that sound like a good word that we used to say? Yeah. What would your scale factor be here? 2. Yeah, because 4 times 2 is 8. 2 times 2 is 4. Okay. It says the rectangles are similar. What's our scale factor? Let's go B to A.
K.
How'd you get K, Nisha?
What is the first one that K and the second one?
Yeah, so let's just break it down for people that don't see that. 5K over 5. How can I reduce that? 5. 5. So K over 1 or just a K. Good word. What would the perimeter of B be? Perimeter of B. You guys agree with B pond? Yes. What would the perimeter of A be? Can I reduce this? To what?
K.
Do we notice anything? Yeah, these guys are the same. Do you want to write that? Your scale factor and the ratio of your perimeters are the same. So if you have one, you know the other. Okay, one more little thing. What's the area of B?
Of B, 49K times 5K.
45.
Squared.
What's K times K though?
Squared.
Squared. What is the area of A? 45. How does this reduce? Is there a way, do you think, that we could go from here to here?
You multiply them by each other.
Yeah, you square. What's K squared? K squared. What's 1 squared?
1.
That's our big idea today. If two polygons are similar, the ratio is A to B. If you want to find the ratio of their areas, you just square it. What if I wanted to go the other way? If I had the ratio of the areas, how would I get their scale factor? Just back and forth all day. All day.
Can you go back, Bundy?
Yeah, I sure can.
Good. Good conversation.
Thanks.
No. So on these problems today, I like to give myself a little roadmap so I don't get lost, because it's easy to get lost. But like, Jack, are you good?
Yeah.
Okay. On the first one, it says, for each pair of similar figures, find the missing area. So let's just give ourselves a little roadmap here. Let's start with our scale factor. SF stands for scale factor. What would my scale factor be?
-3.
So you're just going to pick two sides and write a ratio. So I only know these two, right? So
Yeah.
5 over 8. Now let's put the small one on first. On top, excuse me. Okay, now from here, how do I get to the ratio of our areas? I'm going to abbreviate it to ROA. What do I have to do to this? Yeah, did we say if we're at A to B, we take A squared to B squared?
Ratio.
Yep. So what is 5 squared? 25. What's 8 squared?
64.
Okay, so we're cooking now. So now from here, you can write a proportion and cross multiply. So you're going to start with this, the ratio of your areas, 25 over 64, and set it equal to, do I know the area of the small guy?
No.
So what can I I know the area of the big guy?
22.
32. And now I know you guys know how to solve proportions. We've done that before. How do you solve it? Cross multiply. Okay, get a head start, and I will join you. Do you guys get 12.5? Yeah. So that's really what we're doing today. Thank you. Okay, let's try another one just like that. So where do we start? Scale factor. What would our scale factor be? 6 to 8. And I agree with Gabe, I think you should reduce 2 to thirds. It makes your life easier. Oh, it's not 2/3.
3/4.
There we go. 3/4. Okay, now where do I go?
Square it.
Yep, the ratio of your areas. Square, square. And then now what do you set up? A proportion. Does 13.5 go on the top or the bottom? Because it's the small one. Because 13.5 goes with the small one, and since our small number's on top, it has to match. Otherwise, you might get the wrong. 24 feet, everyone? Yep, feet squared. Can we go the other way now? Can we work backwards to get our scale factor?
Yeah.
Let's just try it. So this time we have our areas and we need to get back to our scale factor to find x. So start with the ratio of your areas. So that'd be what, 50 over 72? If we reduce, what do we get? Because I can divide them both by 2, right?
Yeah, that's right.
Because now we'll get nice numbers. Yep, now you're going to take the square root. So working backwards.
So it's 5 over 6.
5 over 6.
But how do you know the first one's 5?
What's the square root of 25?
Yeah, but like, where'd you get the 25 from?
I reduced these by 2. So I could get nice numbers when I took the square root. And now you can write your proportion to find x. So we'll have 5 over 6 equals, okay, does this 6 go on the top or bottom? Because it's with the big one. You guys get 5 just inches on this one. Okay, you guys start the next one. See how far you get before you get stuck.
What if we don't get stuck?
You can get a sticker.
Yay!
I'll write out the roadmap.
I did. So if I get like 20 over 8 like that, I can reduce that even more. So I could do 2 or 5 over 2.
Wait, you get a sticker?
Because 4 or 4.
You want to reduce this, so I write 64 over 400.
Okay, I get
Yeah, well, because that, and then the square root of that, the square root of that was, oh, I can do it to 0.
I would say
What?
What's it doing?
What sticker?
You can reduce by 4.
Whoa.
You can reduce by 8.
So it'd be
I'm gonna put on my
20.
sheet.
So it'd be 20 over
Boom.
8.
Yeah, put on my sheet.
So it'd be 20 and 8.
Can you reduce by 4? We're getting
Because you said you divided both by 8, so when. Oh, no. That's okay. Wait, the square root of 2 is. Oh, yeah, that's like 8. That's
Hi. Thank you so much.
Do I get sticker?
Yeah.
Did you get 16?
Yes.
Good job.
I know. I got 25.
Good job. That is not
Yeah.
with us.
Yeah, that's 25.
Wait, wouldn't it be before 4
I didn't work on it.
64 instead of 64?
Yeah, that's what I got. I got
Yeah, it should be
square root of
25.
4.
I did not.
Sorry, guys. Now are we fine?
I'll take
Are we fine now? Thank
Yeah.
you. Sorry, guys.
Actually,
What's the square root of 4?
no, I got 2 over 5.
Gee, that was pretty good.
That's what I did wrong. I started looking at the previous problem for when I set up the proportion, so I did 2 over 5 is equal to x squared.
Are you good now?
Yeah, I'm good.
Are we okay with 16?
Yeah.
Okay. One more. Just a little application, but it's the same process. The area of one side of a skyscraper is 90,000 square feet. The area of the corresponding side of a scale model is 20 square inches. If the scale, geez Louise, if the skyscraper is 720 feet tall, about how tall is your model? So what do we know the area, or what do we know both of? The areas or their scale factor? So start with the ratio of your areas. What's the area of the model?
A lot of feet.
You don't have to convert on this one. What's the area of your skyscraper? Can you reduce that?
Yeah.
Yeah, by a lot.
5 to 5.
Think your zeros go away. Can I simplify that even more?
Yeah, 1 over 450.
1 over 450. Good work. Now we want to get to our scale factor. So what do we have to do? Square root. What is that?
22.5.
I got 21.2.
Oh, I just guessed it.
Oh.
Okay.
And then set up your proportion. Does 720 go on the top or the bottom? Bottom.
Equals
About 34?
33.9 rounded. 34.8.
I have 2 problems to do on our desk. Do you guys want to do them, or do you feel confident that you're okay? You guys are okay? Okay. Good work, team.
Middle name.